All right, we're back for more exciting algebra topics. Now we're going to go on to P.6, rational expressions. Um, so what we're going to do is cover basics about a rational expression, partly like about domain, but later we'll have a more formalized definition of domain. So expect there to be a little change here. Talk about simplifying expressions, multiplying rational expressions, dividing, adding, subtracting, and simplifying complex rational expressions. So, a rational expression, its name comes from a rational number. So a rational number is essentially numbers that you can write as fractions. A formal definition is a quotient of two integers. So rational numbers could be like 2 over 5, because 2 and 5 are integers. It could be negative 2 over 5, because we can also have negative integers. But also it can be things like bigger number on top, that's fine. So let's pick some inside divisible by 100 divisible by 3. That's still a rational number. But technically something like 2 and 1/2 is still a rational number because I can rewrite that as 5 halves. So it's still a quotient of two integers. And 3 is still a rational number because I can rewrite it as 3 over 1. So it's still a quotient of rational numbers. All right. So when we talk about rational expressions, a rational expression is a quotient of two polynomials instead. So your rational expression would be like over x squared minus 5x plus 2 would be a rational expression. That being said, notice like 3 here is a rational number. So technically 2x over 3 over 5 is still a rational expression because 5 can be a polynomial. You can have 1 over the x squared 3x because 1's still a polynomial. So those still count as well. Or even 2x plus 3 by itself, because technically that's just 2x plus 3 over 1, and 1 is still a polynomial. So there's a big variety of ways that technically, if I have an expression that is equal to 3 halves, it is a constant, but still it counts as one of your rational expressions. So polynomials are still rational expressions. Constants are still rational expressions. It's, like I said, a lot of things fall under it, but usually when we talk about rational expression, we're really looking at things like these ones. Out of the way. The set, your domain is all your input values or all your x values for the most part that you put into a expression that basically can be defined. So it means that if I put it in, another number should come out. So the set of real numbers and for which the algebraic expression is defined is the domain of the expression. Like I said, let me just put in here. So defined means it means an input will produce an output. So because a rational expression indicates division and division by 0 is undefined, we must exclude numbers from the rational expressions domain that make the denominator 0. So what we mean by that, so x plus 2 is defined. Because no matter what I plug in for that x, if I put 1 in there, we get something back out. If I put 0 in there, we still get a number back out. There's not really anything I can replace that x with that I'm not going to get an output of some sort. Let me get this up here. So the problem is when we divide by 0, that is when We're undefined. So if I had 3 divided by 0, that's undefined. So if I have an expression, oops, I have 3 on top. If I have 3 and then I put x on the bottom there, that's a polynomial over polynomial, it's a rational expression. This is defined for all x except x equals 0. So when x equals 0, what we have here is we're going to have, it's going to be undefined that spot. So this expression is undefined at x equals 0. This is going to seem a little weird because when we're looking for domain here, what we're looking is for numbers that we exclude. Because then later when we talk about domain, we're looking for numbers that we include. So bear in mind that what we're looking for is we're just looking for all the values for which it is defined. So to add to this, if I was to talk about the domain of x over 3, what we could say is that the domain is going to be all values from negative infinity up to 0, and then all values from 0 to infinity. So everything except that 0 is the only thing we skip over. Something to bear in mind because when we talk about simplifying, the domains are causing an issue when we're simplifying. So we want to find all numbers that must be excluded from the domain of this rational expression. So bear with me because I'm trying to go along with your book here. So we want the values that are excluded for the domain. So we're looking for values of x and make the denominator 0. Because then if the denominator is 0, then we're undefined. So if the denominator is 0, the expression is undefined. So remember, if it's undefined, it can be in my domain. So we did do factoring. So what we want to see is we want to know where is x squared minus 5x minus 14 equal to 0. Because when it's 0 on the bottom, that whole expression will be undefined. It doesn't matter if it's 0 on the top, as long as it's 0 on the bottom, we're undefined. So we only care about the denominator. Okay. So this is one of those places where your book does something a little out of order here. Bear with me. Ideally, you have done this before, but if I wanted to solve this polynomial here, I have x squared minus 5x minus 14 equals 0. One of the things I can do is I'm going to factor. So I'm going to leave this 0, but this part gets factored. And if we factor that, we just need 2 factors that multiply to give me negative 14, but add to give me negative 15. Well, that'd be negative 7 and plus 2. So because we have x minus 7 times x plus 2 equals 0, we have this property that says if I have 2 expressions multiplied together and they equal 0, then one equals 0 or the other equals 0. So what we know here is that x minus 4 has to equal 0 or x plus 2 has to equal 0. So if you solve those for x, add 7 to both sides, x equals 7, minus 2 from both sides, x equals negative 2. These values make the denominator equal to 0. Got a little bit going on here, but just do a little demonstration here. So let's say we have x is, well, let's pick -2. That's a smaller one. So if x is -2 and I plug it into my expression, I have 7 times -2 on top divided by -2 squared minus 5 times -2 minus 14 on bottom. That is going to be -14 on top, which isn't going to matter because on the bottom, I'm going to have 4 plus 10 minus 14. So I have minus 14 over 14 minus 14 minus 14 over 0. So as we see that if x is -2, we have a 0 in the denominator. So that's all we did here. So if you have that polynomial, you need to factor it at both factors equal to 0 and then figure out what those x values are. So we exclude x equals -2 and 7 from the domain. So if we were actually to talk about what the domain would be, your domain would end up being every value from -infinity up to -2. We skip -2. And then we go from -2 to 7. But then we have to skip over 7 because 7 can't be included. And we go to 7 infinity. So what that's doing is just making a number line like this. And we're just making open points at 0 and 7, but that's representing my domain. Make sure this is working. So we're still going to talk about that domain, but first we're going to talk about simplifying rational expressions. So simplifying rational expressions means what we're going to do is we're going to make sure that the denominator and the numerator do not have common factors other than 1 or -1. So the following procedure can be used to simplify rational expressions. So this is like simplifying fractions. So if I had 14 over 21, we know that it's 2 times 7 and 3 times 7. So really when we're simplifying fractions, what we're just doing is finding this common factor here, 7 and 7, that cancels. I'm left with 2 over 3. We're going to do a similar thing here. So we're going to, instead of factoring a number, factor the numerator and denominator of our polynomial completely, and then divide the numerator and the denominator by any common factors. So like we did here, that common factor of 7 could disappear. Here we're going to see like a binomial disappear. Okay, so we want to simplify the following, and then we figure out values excluded from the domain. So I'll give you another example of this, but first thing we want to do is we want to look at domain. So I'll show you later why that matters, but first thing you always want to do is before you even start trying to simplify is find the domain. So first find domain before simplifying. So that means I have to take the denominator. So it's the x squared plus 2x plus 1 and set it equal to 0. We don't care what happens on the top. That bottom, we can't have the bottom be equal to 0. So we're going to set it to 0 to figure out what do I need to remove. Once again, if I factor this, I need 2 factors that multiply to 1 and add to give me 2. Well, that's just going to be x plus 1 times x plus 1. So we have not really 2 choices, but my choices are either x plus 1 equals 0 or x plus 1 equals 0, which is going to be the same factor. And we're going to get, well, if x is -1, the denominator will be 0. So we're going to exclude x equals -1 from the domain. Now we're going to simplify. So first thing we want to do is factor. So we're going to take x squared minus 1 divided by x squared plus 2x plus 1. And we already factored the denominator because we did it over here. So we know that factors into x plus 1 and x plus 1. So we have x squared minus 1 on top. That is a difference of squares. That's an x squared minus 1 squared. So that would factor into x minus 1, x plus 1. So what we see here, we have the same factor on top as we do on the bottom, and we can eliminate factors as long as we just have multiplication going on. If we were adding these binomials, that'd be different, but because we're multiplying, that's when we can cancel out. Because essentially what I'm doing is I'm just saying I'm going to divide by an x plus 1, get rid of this one, and then I'm divided by here by an x plus 1 to get rid of this one. Or you can just say, I cancel them out. But that's just going to leave me with an x minus 1 and an x plus 1. And if you check this one, once again, we would see the domain is all values except one we have to exclude. We still have to exclude x minus 1. So in this case, x squared minus 1 divided by x squared plus 2x plus 1 is just going to be the same thing as saying x minus 1, x plus 1. And I'm going to put this little note here for all x values. That's because the domain is matching. So sometimes when you simplify, it's going to kind of change your domain. So here, we want to do the same thing. We want to simplify and find values we have to exclude from the domain. So we'll see why I'm doing the domain first. So I'm going to find the domain first. So remember, we're only interested in what happens on the bottom. So we just take x squared plus 4x plus 3, and we want to figure out where that equals 0. So I need two numbers that multiply to give me 3, but add to give me 4. So that'd be x plus 3, x plus 4. They multiply to give me 3, and they would add to give me that 4. So either x plus 3 equals 0, or x plus 1 equals 0. Or we'd say x is -3 or x is -1. So these two values, if I plug them into this polynomial, will result in the denominator being 0 and it is undefined. So we exclude x equals -3 and -1 from the domain. So notice here that when I write the numbers that I'm excluding, I am putting them in numerical order. I'm going smallest to largest. You'll have to do the same in your homework. Okay, so now we're going to simplify. So I have x squared minus x minus 2 divided by x squared plus 4x plus 3. So we factor both the numerator and the denominator. We already know the denominator is going to factor into x plus 3 and x plus 1. Now the numerator, we need two numbers that multiply to give me -2 and add to give me -1. So that'd be x minus 2 and x plus 1. So we multiply those, we get -2. If we add them, we get -1. So we should see x plus 1 is a common factor. So this is the one that's going to get eliminated. So sometimes you might go through this process and realize that you can't simplify. So just bear that in mind. Not every rational expression can be simplified. But we're going to be left with x divided by 3, or sorry, x minus 2 divided by x plus 3. Kind of missed the term there. So this is my simplified form. So notice this is only defined, only undefined, when x is -3. If x is -3, then the denominator is going to be 0. So there's a problem here. So technically, we would say that these are equal expressions. Well, not technically. We will say that, but technically we shouldn't. So what we have here is that when I factor this, and then I find this factor to eliminate, what happens here is that these are almost exactly the same. Here we had to exclude x equals -1 and -3. And in this one, the only thing we have to exclude is x equals -3. The problem that we have here is that what if they do not have the same domain? So for two things to be equivalent, they are supposed to have the same domain. So these are really equivalent fractions or equivalent expressions. So these are not truly equivalent expressions. We are equivalent everywhere except one spot. Oops, everywhere except, so they both have -3 as a point they exclude, was this one that gets left out. So they are equivalent everywhere except at x equals -1. There, we got kind of tight in that little area there. So bear with me a second, and I'm going to show you what the graphs are going to look like. All right, so you see on the side, I have the two equivalent expressions. And if you look here, well, if I turn off x minus 2 over x plus 3, it's sitting right on top of x squared minus x minus 2 over x squared plus 4x plus 3. They're sitting right on top of each other. Now remember, we said that this one was undefined at, trying to hit the spot. Not let me hit the spot exactly. Okay, we'll do it here. Oh, because I'm on the wrong side. Sorry, that was just me being a little dumb. So the red one, we said it was undefined at, there we go. It was -1, not +1. So at -1, it was undefined. And then at 3, which will be way down here, might have to do this. It's not working so well. Let's do this. We'll just look at the charts instead of the graph. So as we see, it's going to be undefined at -1, -3. So really what happens there, I'm sorry, it's not fitting on my screen very well. So at this point that we marked right here, where we said was undefined, technically we have an open circle there at -1. And then we'd have another open circle at -3. It's just I can't show that. Oh, I can't show that because of the asymptote. That's what it is. There's an asymptote here at the 3. That's why you don't see anything. And then here, there's an open point. So it's undefined these two places. Now, if we look at the other one, so when it's blue, right, I do not know what it's doing here. What we see here when it's blue, we still have that asymptote. But now, if you look at -1, it says there's a value there. So here, if x is -1, we don't get y as undefined, we get y as, what was it, 1.5? So what we have here is, like I said, they look almost exactly the same. It's just that when you simplify, you actually hide part of your domain. So that's why we have the situation here that technically these are the same, except at x equals -1. So one of the things you have to be careful with is this is why I was looking for domain first, is that even though I simplify it, we need to still specify that this part here, we still have to exclude the point of x equals -1 because originally that was excluded in the domain before we simplified. I know that seems like a lot. That's why we're going to practice it a little bit more here. Okay. Um, so as we see here, note that the simplified form of the rational expression is not always equal to the original form everywhere. The expression that we had for the x squared minus x over -2 over x squared plus 4x plus 3 is not defined when x is equal to -3 or when x is equal to -1. The simplified form of x minus 2 over x plus 3 is only undefined when x is equal to -1. Or, sorry, -3. That was a typo there. This one's only defined when x is equal to -3. So we have to make sure that we specify that the point had to have been removed. So what we would really need to say is that x squared minus x minus 2 over x squared plus 4x plus 3 is actually equal to x minus 2 over x plus 3 with this extra condition that we can't have x is equal to -1. That ensures that then these are equal, because otherwise they're equal everywhere except at x equals -1. So don't worry about you can try it, but it's like don't worry about that trying to put that condition on there so much, as make sure you find your domain first, then simplify. Then you can try working with that extra condition that happens after being simplified. If you're a little iffy on it, don't worry, we're going to go back through it again, but just attempt these problems and we're going to come back. Okay, so we'll start with A. So if we talk about the domain, we're going to take x squared plus 9x plus 20 and set that equal to 0. So it's always the denominator. So two numbers that multiply to give me 20, but add to give me 9. Well, that'd be x plus 5 and x plus 4. So either x plus 5 equals 0 or x plus 4 equals 0. But in either case, we get that the numbers that we have to exclude from the domain, the ones that will keep the domain from being 0, would be -5 and -4. So your domain excludes x equals -5 and -4. So we'll see what happens after we simplify. So I'm going to be going a little above and beyond here just to prepare us for the future. But when we simplify this, the top, we have a difference squares again because that is a x squared minus a 4 squared. So that is just x minus 4, x plus 4. And then we already did the denominator. We did it over here. So we know that turns into x plus 5 and x plus 4. So we're going to see we are going to lose part of our domain when we simplify. So that x plus 4 disappears, and our simplified form is going to be x minus 4 over x plus 5. So the domain only excludes the minus 5 still. So this one is the extra that we have left over. So that little extra part here, so it is the same as long as we say x also cannot be negative 4. Because now that ensures that I can get negative 4 out of this problem as well. So now they'll be equal. All right, we're going to work on B now. So the domain of B, we're going to look at x squared plus 5x plus 6 equals 0. Also bear in mind that sometimes when you simplify your domain, you look at your domain, there's not going to be anything you can exclude. We're just using examples that can have something excluded. But if we factor this, two numbers that multiply to give me 6, but add to give me 5, so that'd be x plus 3 and x plus 2. So what we'd see here is either x plus 3 equals 0 or x plus 2 equals 0. So we don't want x to be negative 3 or x to be negative 2 because if x is negative 3, then my denominator is 0. If x is negative 2, my denominator is 0. So the values that we have to exclude from the domain will be the negative 3 and the negative 2. So when we simplify, so 2x plus 4 over x squared plus 4x plus 6. So on top, the only thing that we can factor is that both of these are divisible by 2, so we can take out a greatest common factor. So that's just 2 times x plus 2. And then the bottom, we know that factored into x plus 3 and x plus 2. So x plus 2 is going to be eliminated, and this simplifies down to 2 over x plus 3. Or sorry. So what we see here is that what we can visibly see is that we have to exclude the negative 3 still, or that's going to be 0. But what got hidden is that negative 2, so we just add on here. Well, x also cannot be negative 2. So we're going to have 2 x plus 3, but we have to remove that x negative 2 because that is the one point that is removed from my domain that I cannot see in the simplified form. All right, this is my last one. To see the domain is going to be really easy. We got 2x equals 0. So the only thing that x can possibly be, because 2 stays 2, so what we do, if we divide both sides by 2, then we get just x is equal to 2. So my excluded value, or sorry, x is equal to 0. My excluded value, exclude from domain, we would exclude that x equals 0. That's the only thing because if x is 0, the denominator is 0. It's the only thing I have to worry about. So when I simplify, we get 4x cubed minus 6x squared over 2x. So the top, we can factor out a 2 and an x squared, leaving us with 2x minus 3. And then we have 2x down here. So the 2's will cancel in at least one x, leaving us with just x is x times 2x minus 3. And this is still a rational expression because we could just put 1 under it and it's still two polynomials. Or you can say it's 2x squared minus 3x. All right, so notice that we can't see the 0. So here, domain appears to be all real numbers. Yeah, see close the bottom screen there. Appears to be all real numbers. So what we need to do is that we know 0 didn't work here. We have to make sure that 0 is not going to be included here. So this would be 2x squared minus 3x, and x cannot be 0. So now we have that both rational expressions will be equal now. All right, so a little less insane. So now we're going to be multiplying rational expressions. We want to do this. It's going to be like if we had two fractions and we were multiplying them. So we were multiplying these two fractions. One of the things we could always do is we can always factor everything. Actually, let me change that. Put my numbers in the wrong place. 14 over 10, 25 over 21. So if we were factoring these, we would see, well, this is a 2 and a 7. This is a 2 and a 5. We see here this is a 5 and a 5. We see here that that is 3 and 7. So we have done this once again. You may have done this with fractions at one point, but we see we have 7 up here, a 7 down here. They're going to cancel. The 5 and the 5 would cancel, the 2 and the 2, and we're just left with the 5. It's going to be a similar thing again, except this time it's going to be factoring polynomials. So we're going to factor the numerator and denominator completely, divide numerators and denominators by common factors. So if it's on the top and the bottom, we can cancel it out. Multiply the remaining factors in the numerator and multiply the remaining factors in the denominator. So if we had 3x over x squared minus 4 times x squared minus x minus 6 over x squared plus 6x plus 3. So first thing we're going to do is we're just going to factor everything. So x plus 3 doesn't factor, that stays the same. But x squared minus 4, well, that's just x squared minus 2 squared. So that will factor into x plus 2, x minus 3. So in here, there's nothing to cancel out, but we're multiplying to another polynomial. So we have x squared minus x minus 6. So I need, my line a little too big. I need two numbers that multiply to give me negative 6 and add to give me negative 1. So that'd be x minus 3, x plus 2. So those multiply together, give me negative 6, add for negative 1. And then we have x squared plus 6x plus 3. I don't know if you noticed this one. This is x squared plus 2. Sorry. 2x times 3 plus 3 squared. So this is actually one of those ones that is a perfect square. So what this factors into, if you were looking for two numbers multiplied together that give you 3, but add to give you 6, it's x plus 3, x plus 3, or it's really just x plus 3 squared. My suggestion, Leave it like x plus 3 and x plus 3 for now. So we just start looking for things that are common that we can eliminate. So it has to be in the top and bottom. Remember that this all multiplies together, everything across the top. So that's really just x plus 3 times x minus 3 times x plus 2 on top. And on the bottom, it's just going to be x plus 2, x minus 2 times x plus 3, x plus 3. So technically I should have done the domain first. I just wanted to do this part first. It's going to take more room. But we'll get back to that domain. So this eliminates, and this eliminates as a common factor. The x plus 2's eliminate as common factors. And what I'm left with is an x minus 3 on top, x minus 2, x plus 3 on bottom. Then your very last step is that we just want to multiply this out on the bottom. So this is x times x squared, x times 3, so 3x, negative 2 times x, so negative 2x, and negative 2 times 3, so negative 6. So what we would have after we multiply and simplify is x minus 3, and then we're going to have x squared plus x minus 6 on the bottom. Okay, so let me get back to domain. So when we're here, this is where we want to find domain. Sorry, it's getting a little funky here. So let me pause. I'm going to pause this and restart it. Okay, so getting back to domain. You always want to find domain before you simplify. So find domain before eliminating factors. But what we see here is that we get an x plus 2, so things that we would have to exclude from domain the following values. So here we know if we set this to 0, we just get 2. Here we just get negative 2. Here we get negative 3, and here we get negative 3. So we only need to record the number once. So the things we would have to watch out for are negative 3, negative 2, and 2. Those are the things that have to be excluded from the domain. So now we eliminated factors. What we can see is we only see that we shouldn't have x equals negative 3 and x equals negative 2 are excluded. So what we have here is this plus 2 is the one that was hidden. So we just make sure, once again, that we just say, well, this is all true, just as long as x is not positive 2. As long as x is not that positive 2 that we hid by simplifying. So we just have to remove that point is all we're doing. So when we talk about exclude from the domain, that's going to come back from what I originally excluded, which is just going to be the negative 3, negative 2, and 2. That's what's excluded. And then when we simplify, this is the only thing that we have to note is still excluded because the other two are already out by the, are already in there as factors that we have to eliminate. Take a moment and simplify both of these. So remember to factor them. Once you factor it before you start eliminating factors, that's when you want to look for values to exclude from the domain. All right, so we'll start with A. So we'll factor first. So what we have here is that we have a, a 3a squared, a 6a, and a 3. So we can pull out a 3 from all of those, leaving us with a squared plus a plus 3, which I believe, let me think. Yeah, we cannot factor that one any further. Oh, sorry, I did that. I don't know what I was doing there. With the wrong thing or something. We didn't pull out the 3. We were left with a squared plus 2a plus 1. There we go. That can't be factored. On the bottom, we have a squared minus 3a minus 10. So we just need two numbers that would multiply to give us negative 10, but add to get us negative 3. So that would be x minus 5, x plus 2. So we'll factor this a little further. This one just has an extra step. So we have an a squared minus 4. So remember, that's just an a squared minus 2 squared. So that's going to be a difference of squares. And then here we can factor out a 12, leaving me with a squared minus 1, which is also another difference of squares. Because we have to be 1 squared. This is 3. New two numbers that multiply together give us 1, add to give us 2. Well, that just be a plus 1, a plus 1, divided by x minus 5 times x plus 2. And then the other part is we'd have a minus 2 times a plus 2. And then below that, we would have the 12, a plus 1, a minus 1. So I'm going to find my domain here. Domain is all values except what we're going to exclude is if we have, if x is 5 here, then we have a 0 on the bottom and we're undefined. If x is negative 2 here, we have a 0 in the bottom, everything's undefined. If x equals negative 1 here, or not my x, sorry, my a's. I'll go back and fix that quickly. I just accidentally switched variables halfway through this. So if you do that, don't feel bad. It happens all the time. Because you're used to those x's. All right, so what a cannot be, a can't be this 5, it can't be negative 2. Here, if a is negative 1, then we'd have negative 1 plus 1, which is equal to 0. Here, if a is 1, then we have 1 minus 1, which is also equal to 0. So we have to exclude negative 2, negative 1, 1, and 5. So to keep simplifying, so what I can eliminate is, let's pick this color here. So we have an a plus 1 on top, a plus 1 on bottom. We can get rid of those. We have an a plus 2 on the bottom and an a plus 2 on the top. Those can go away. We have a 12, a 3 divided by a 12. We're going to put that over here, but that's going to have to go a little further. So we'll have the 3, a plus 1 times a plus 2. Because when we multiply across top, we still keep that. If we multiply across the bottom, we're going to have that 12. The a minus 5 and the a minus 1. So 3 divided by 12, that's going to leave me with a 4 on the bottom. And then if I FOIL, I'm going to have a squared plus a plus 2a times 2. If I FOIL my a minus 5 times my a minus 1, then we're going to have a squared minus 5a minus a plus 5. So this will all simplify down to a squared plus 3a plus 2 'Cause we're running out of room, I'm going to distribute this 4 across while I do this. So this will end up being 4a squared. We're going to have -1 and -5. So -6 times -4. So second, 24. Yeah. Sorry, I got myself a little off track there. Yes, -6. So -24. And then we have that 5 times 4 plus 20. Notice that the only thing that's excluded here is that x cannot, is the -5 and the -1. So what gets hidden, right, what we still see here is the 5 and the 1. So it's these two that we don't see. We just make sure that right after this we say, or a, because that's my variable, a cannot be -2, -1. Okay. So pause here a second. If you need to pause, I'm going to break the screen so we have room so I can show you B. So we're not squished all the way at the bottom here with B. We're going to go like this with it. So if we have this, we can't factor anything on the top. We're just left with 2x plus 3. The bottom, we can pull out an x, and then we just have x times x plus 5. And that's the best we can do there. X plus 5, that can't be factored either. That just stays x plus 5. And this is going to require us to use AC method. So I have 4x squared plus 4x minus 3. So AC is going to be the 4 times the -3, which is -12. I need two numbers that multiply to give me -12, but would add to give me that 4. So what we would have is 6 times -2 will multiply to give me -12, and 6 plus -2 will add to give me 4. So we have 4x squared. So remember the 6 and the -2 break up this middle term. So we'll have plus 6x minus 2x minus 3. So we can pull out here a 2 and an x out of the first two terms. So that's 2x, and we're left with the other 2x plus 3. Here, with these two, the only thing we can pull out is a -1. So we can pull out the -1, and then we're left with the 2x minus 3. So if I factor out the 2x plus 3, what's left over is the 2x minus 1. So 4x squared plus 4x minus 3 factors into 2x plus 3 times 2x minus 1. This is the first time we had to use an AC method in here. Okay, so we're going to look for our domain before we keep going further because we got everything factored. So we can just look at the denominator. So if anything in the denominator is 0, we do this. So we put that whole denominator together, it's going to look like this. We don't want any part of this to be equal to 0. So what I'd have to exclude is this. I couldn't you have x be 0 because then this becomes 0. X plus 5, if it equals 0, that only happens if x is equal to -5. 2x plus 3 equals 0 only if we solve this for x is equal to -3/2, or if 2x minus 1 is equal to 0, which if I solve simplify, or not solve that, solve for x, we're going to get x is equal to 1/2. So we exclude from the domain. What has to be excluded is that x cannot be -5. It cannot be -3/2, it cannot be 0, and it cannot be 1/2. So now that we have the domain, we can start simplifying. Always factor, find domain, then simplify. So this and this eliminate, this and this eliminates, and I'm left with, remember, if there's nothing here, there's always this invisible 1. There's still a 1 on the top. On the bottom, we're just left with x, 2x minus 1, which simplifies into 1 over 2. Sorry, that was a little messy looking. Let me fix that just a little bit. X, 2x minus 1, 1 on top, and that will end up being 1, 2, x squared minus 1. So we see here the only thing that we can see is the 0 and the 1/2. So these two places that we know that we have to be excluded from the domain are not here. So we just put on this. X cannot be -5. Make myself just a teeny bit of room here. And my writing tool disappeared. There's my writing tool. I know you can't see it, but yeah, my writing tool just disappeared on me. We just have to point out that x also cannot be -5 and -3/2. So going back to fractions again, so if you had two fractions and you wanted to divide them, so if you had a over b divided by b over c, the way we would deal with this is that we would take this part, the second fraction, and then it inverts, and we change division to multiplication. So this is where you have this keep, change, flip. Well, we can use the same thing when we're dividing by rational expressions. So if we have one rational expression, we divide by another rational expression. We're just going to turn to multiplication. And we already know how to deal with multiplying two rational expressions. Not much is going to change past that. So if you have 2x x squared minus 2x plus 1 over x cubed plus x divided by x squared plus x minus 2 divided by 3x squared plus 3. The first thing we want to do is do keep, change, flip. So we're going to do x squared, and we're going to still look for what's excluded from the domain. X squared minus 2x plus 1 by x cubed plus x, and now it's going to be times. And this flips, so now it's going to be 3x squared plus 3 on top, and the x squared plus x minus 2 on bottom. Now, we have something we're familiar with, so we just need to do the factoring. So x squared minus 2x plus 1 factors into x minus 1 minus 1. Think for that for a second. On the bottom, we can just pull out an x, so we get x is equal to x squared plus 1. This doesn't factor any further because it's not a difference of squares, it's an x squared plus 1. So that factor is x going to go. Here we can pull out a 3, so we have 3 x squared plus 1. Once again, that cannot be factored any further. And then x squared plus x plus 2, that would have to be x plus 2 times x minus 1. So here we exclude from the domain x equals 0, x squared plus 1 equals 0, meaning that we'd have x squared is equal to -1. which is undefined. So in that case, there's nothing more to exclude. We just had that 0 there. Here we would have that x plus 2 equals 0. So that means we'd have to take out x, we'd have to exclude x equals -2. And then the x minus 1, when would that be 0? When x is equal to 1. So the only things that we're really excluding are going to be -2, 0, and 1. So like I said, sometimes they'll have a factor, something that actually is not going to be a problem for us. So this one here, that x squared plus 1 didn't factor any further. And in fact, it's not ever going to be equal to 0. So once I have it here, it's undefined. I can't ever make it be equal to 0 because there's nothing I could put into x squared to make it equal to -1, which is going to give me -1 plus 1. As long as we're in the real numbers. All right, we keep on going. So what we have here is that this is on the top and the bottom, so they can cancel. We have an x minus 1 on the top and bottom. That can cancel. I think that's it. So we're left with on the top a 3x minus 1. On the bottom, we're left with an x plus 2. So the only things we see here is that we see that 0 and that -2. So when we know that also we have to add back this 1. This 1 is a factor that got eliminated from the bottom, so we don't see it anymore. So just remember, we also have to say that x can't be 1. And if I simplify completely, that is 3x minus 1, or 3x minus 3, over x squared plus 2x, and just remember, x can't be 1. That way we can ensure that both of these expressions here are equal to each other. All right, so worksheet number 3. Once again, I try to try to divide these and also figure out what values are excluded from the domain. So remember, keep, change, flip, and everything is the same as multiplication. All right. So what we have here, like I said, we want to do keep, change, flip. So that would be y squared minus 6y minus 16 divided by y squared plus 4y minus 21 now times y squared minus 8y plus 15 over y squared plus 9y plus 14. So if we factor two numbers that multiply to give me -16 and then add to give me -6, so that'd be y minus 8 and y, oh no, that wouldn't be it. Oh no, I was right. Y minus 8, y plus 2. Those multiply to -16, add to a -6. Y squared plus 4y minus 21. We need two numbers that multiply to give me 21. So we're going to have a negative and a positive factor. And then they have to add to give me plus 4. So -7 plus 3. Then here, y squared minus 8y plus 15. So two numbers that multiply to give me 15, but add to give me -8. So that would be -5. Oops, y. Y minus 5 and y minus 3. And then the last one, we will have y squared plus 9y plus 14. So two numbers that multiply together to give me 14, but add to give me y. So that would be, or add to give me 9, would be y plus 7, y plus 2, because those will add to 7, multiply to give me 14. So we see here what I have to exclude. from the domain. I can't use a 7 because y is 7. My domain's the y values right now. So if y is 7, then we'd have 7 minus 7, that'd be 0. So that needs to be taken out. I'm not doing these ones in order. Y plus 3, y can't be -3, or we have -3 plus 3, and then we have 0 on the bottom. Y plus 7, so I have to get rid of -7 because if I put in -7, then I have -7 plus 7, which is 0. And then y plus 2, I have to take out -2, or we end up with 0 on the bottom again. So these are what I exclude from the domain are 7, -3, -7, -2. So technically I have to write those in order from smallest to largest. So let me just rewrite that the correct way. So we'd have -7, -3, -2, +7. What can we eliminate? So we have, I actually don't think we get, oh, one thing. I think the y plus 2 is the only thing that is shared on the top and bottom. Yeah, because that's a +3 and that's a -3. So it's just going to be one factor. So we're going to be left with I threw this one in here because you are going to get some that's crazy sometimes. Y minus 8 times y minus 5 times y minus 3. And then you're going to have y minus 7 on the bottom, y plus 3. Get some here. And then you're going to have y plus 7. Okay, so if we do some FOIL, I'm going to FOIL 2 together first. So we're going to leave the 8 minus y minus 8. So if I take y minus 5 times y minus 3, that is going to give me y squared minus 8y plus 15. I'm just kind of skipping a step here. If we do in the bottom, if I rearrange this and I do this as y plus 3 first, and I do y minus 7 times y minus 7, well, that's going to be y squared minus 49, because that's the difference of squares. So if I FOIL further, we're going to have y times y, so y cubed minus 8y squared plus 15y, and then we do the minus 8, so minus 8y squared plus 64y. Okay, I don't know what 8 times 15 is off the top of my head. So the n minus 8 times the fifth positive 15 is negative 120. Yes, you're supposed to do all this. Here, y times y squared is y cubed. Y times 48 is 49, sorry, minus 49y. 3 times y squared, and then 3 times 49. So that would be negative 147. If we simplify this, we have y cubed minus 16y squared. And what's that? 64 plus 15. So we'll have 79y minus 120. Believe it or not, this is simplified because we don't like to keep everything as factors like this because we don't like having extra parentheses. And then the bottom, that's just going to be y cubed plus 3y squared minus 49y minus 147. So after we simplified, the only factors that we still had were these ones. So we still could see that y couldn't be -7, it can't be +7, and it can't be 3. So the only thing that disappeared is this -2. So just make sure we say x cannot be -2. All right, so if you need to, pause because I'm going to erase the screen to do B. All right, so B, all we have to do is just flip or turn to multiplication and then flip the second rational expression. So what you should have is x squared plus 2x over x plus 1 times x squared minus 1 over 2x cubed plus x squared. And we factor out an x. So x squared plus 2x, we can factor in x, leaving us with x plus 2. And then we have x plus 1 on the bottom still. Then x squared minus 1 is just going to be x minus 1, x plus 1. And then here we have 2x cubed and an x squared. So we can take out an x squared, leaving us with 2x plus 1. Okay, so here we're looking for the domain. Domain is going to exclude. So x plus 1, if that is 0, that means that x had to be -1, so that gets excluded. X squared equals 0. That only happens if x is in fact 0. And 2x plus 1 would equal 0 if x is equal to -1/2. So we're going to exclude from the domain just x is equal to -1, -1/2, and 0. So now we can start simplifying. So the only thing, once again, I think I can get rid of is the x plus 1 because that's on the top and bottom, and one of our x's. So we got one x and two x's down here. So that's just going to leave an x behind. So if we keep going with that, we are now left with x plus 2 and x minus 1 on top. And then just, oops, sorry, x. So we kept one of our x's on the bottom and 2x plus 1. So that is going to turn into x squared plus x minus 2 over 2x squared plus x. And what we see here is that we still see that x cannot be 0, and we still see that x cannot be -1/2. So it's this -1 that disappeared. So we just say x also cannot be -1.